I'm Martin. Thanks for coming, folks. And I'm from Berlin, and I'm a programmer and co-founder of Typst. And today I want to talk about the relationships we have with our software tools, about technical writing and typesetting, and the journeys that takes us on. So I want to tell you all a bit of a story about myself first. So when I was in my computer science degree, I just matched with LaTeX. So to those of you who have never heard of the software LaTeX, you might be disappointed by the subject of this talk. Because what this is all about is this is a software for people who write scientific text, technical text, to do it in style, to handle their equations, to handle their tables, and to comply with publisher guidelines. So what this ended up being for me is I used LaTeX quite a lot when I studied at university. And this was in Berlin at Technical University starting in 2016. And during this time, I and LaTeX, we have gone through quite a lot. But you may ask, okay, Martin, why did you fall in love? And the answer is quite simple, because look at this. This is just stunning. Like, have you ever seen this? This is a keeper. And never mind if you're doing something like computer science cheat sheets, whether you're doing a 17th century Bible, or whether you're doing the bullshit that mathematicians do and think like they deserve your credit for. It looks credible, and that's what using LaTeX is all about, looking credible. And I needed that as an undergrad. It has many other benefits. For example, publishers just like the format. It makes you focus on the structure of your document, so you can reformat easily and you don't have to think about formatting a lot. There is a huge package ecosystem for it. And Donald Knuth is just a really cool guy. And it runs on every kind of computer system you could imagine, to a fault. I looked it up, and you get help from the community. All right, so behind every great relationship and every great entity, there is people who made them what they are. And in the case of LaTeX, that story starts at Donald Knuth. And he is a Stanford professor whom you might have heard of, who wrote a series of books called The Art of Computer Programming. So the guy was serious about his craft. And somewhere in 1978, he was like, this whole digital printing shit, I don't vibe with it. Like, it doesn't look quite right. So he was developing his own kind of system for this called Tech. And it's a macro-based typesetting system. And for this, he developed a novel line-breaking algorithm for it to look really nice, to emulate the kinds of results that you would get if you were doing lead type, like on a linotype machine, for example. And then, because he liked doing things thoroughly, he came from a letterpress background, he also designed his own suite of fonts, Computer Modern. All right. Okay, that seems sensible. But then, oh no, he designed the system to write the fonts in. Okay, it's 1978. Maybe there wasn't any prior technology. Okay, we can work with that. Okay, he also wrote DVI, his own document output format. Imagine PDF, but archaic. That's DVI. And okay, surely this all has to do with typesetting. Oh no, he also invented his own programming language to program all of these things in. So he was the progenitor of people who, like today, say rewrite it in Rust. He rewrote it all himself in his own programming language, because why use Rust? Okay, but tech was very low level. It was made for Donald Knuth and Donald Knuth alone. So Leslie Lamport came along, also a US computer science professor, and was like, okay, we sort of have logical structure in our documents and formatting needs to reflect that. So why even bother with explicit formatting when we can just have macros defined that do the formatting for you? So he invented LaTeX. Look, that's his name. And okay, so that's the background of LaTeX. But back to me. and the story I have with LaTeX. Because one night I just was like in the mood to write a seminar paper, and I sort of asked LaTeX, like I went online and asked it, can you put a long URL in the bibliography? Was like, sure, babe. Overfill HBox, Badness 10,000. And okay, I'm not into that. Can I change the color of the text? Right, let's start with something easier. And I wasn't in the mood for that either. So 3 lines of code, you import a package, then you read its manual to come up with whatever this is, and then you can use Orange in your document. How great. And then I'm just, okay, let's get back to the basics. Let's just print a Greek alpha in there. Surely like alpha is the command that will print it. Missing dollar inserted. Crossing fingers, proceeding with caution. And at this point, I couldn't proceed with caution anymore. I had to re-evaluate in what context me and my computer and the software on it stood, and was like, hey, LaTeX, it's not you, it's me. And at that point, I was sort of like, okay, I still need to complete my degree, unfortunately, or I think I do. And so I need to something to write my papers at. And so you might think text processors, LibreOffice, Word, Pages, and that's a non-starter. We try to like do the whole LaTeX thing, to write good equations, to work with tables, to submit to publishers, and that's just not a good software. A lot of manual work involved there. Word moves your images. Let's not talk about this. So I went online and started looking at other alternatives, right? And the first one I came across was pay-to-line. Nice stuck. And the system is like takes the content up here and ingests it and does it down there. Like there seems to be a whole ingestion metaphor going on with document typesetting systems. All right, but the big bummer here is last release 2022 in May doesn't seem very actively developed, and it's sort of halfway done. So okay, let's move on. And another popular LaTeX alternative is Sile. And Sile is really focused on even improving on what makes us love TeX so much. And this is making great looking documents. Simon did it because he wanted to set like the best ever looking, I don't know, whichever century Bible, and he needed more technologies than were available in TeX. And I'm just like, wait a minute. Why did we break up in the first place? It was user experience. It wasn't that the documents that LaTeX did for us weren't nice looking enough. Was that I was going through a bunch of shit with it. So I got together with a friend and we built our own thing instead in Rust. I ruined the joke. And the first thought we had is, okay, we're using Markdown for so much of documenting software and frankly every kind of basic documentation task you have on the web. Couldn't you approach writing documents in the same way for the basics and have this really human readable, easily digestible like form of marked up text? So we started with that. We started by just stealing a bunch of shit from Markdown and ASCII-Doc and just replacing commonly used commands like env with it. And in practice, this looks like this. You go about a serious topic, like in this case, airborne vegetables, right? Eating healthy is important. And you do, emphasis, like italic text with underscores, and then you add the author's handle on Instagram and get this nice reference. And then you have this list here. And finally, some math. And this should look really familiar to anyone who's ever written LaTeX, but less different brackets. Looks like a normal function invocation down here. All right. So the next thing is, okay, we now have basic markup, like the basic building blocks of our document. But we don't want to, if we wanted to stop there, we could just use Markdown and print a PDF from Chrome. Nobody wants that. That would be too easy. And so instead, we need to think about customization. And how do we do customization in LaTeX? So the first thing you could do is say, okay, it's all macros. We'll override the macro. How hard can it be? Turns out very. And next thing you do is, okay, there have been a bunch of smart people before me who did this sort of thing. And they wrote a package. And I can just load that. And okay, you go on C10 and read a 60-page manual, and this is not how you imagined that. And finally, you go to say, okay, I really like, I'm starting my own journal here. Like, I don't like academic publishing, how it's happening. Like, all these publishers are rent-seeking assholes. And so you're doing that, and you're creating your own document class, and it turns out that they have something over you, namely they employ one of the 5 people in the world who know how to write a LaTeX document class. So we thought again, like, how should our relationship with types look? Like we're at the build your friend stage here, and so I want to change the font to Helvetica. Set text font Helvetica. Okay, this looks nice, but is this a cherry-picked example? Next thing we were thinking about is, let's go back to the change the color example. Okay, I want to make this text red. Sure. Set text fill RGB color code. Okay, we're setting text properties, and it's working like with the same. We call it a set rule. And then, okay, you think I now need my bibliography to be in an IEEE style. Surely this is a different subsystem that is configured differently. No, it isn't. And because you just put instead of text, because you're now configuring the bibliography, you're configuring the style because that's an argument. You see, this is quite a lot like a function invocation for those of you who program. For those of you who do not program, it's just the stuff you want to configure, what you want to configure about it, and what to do about it. All right. So the next thing would be, okay, hey guys, I like that you provided all of these kind of screws that I could turn so it can change how my document looks, and but I don't like any of it. So I just want to use the same semantic elements and replace them with my own implementation. And it turns out you can do that. For example, I want to have a box amount around my code blocks that is like light gray, has rounded borders, so it looks like on GitHub. And I just use this show rule. And it says, take the raw blocks, then I provide a function that it will execute for all of my raw blocks. And it says like the content that goes in the raw block, right? We put it in a rectangle, make it the width of the page, make it have a bit of inner padding, have it have rounded corners in relation to the font size. That's this AM unit. And we already saw how to do colors. And just to fill RGB color code, that's a nice gray. And then put the whole code block in there. How nice. And that's all you need to do to redefine that. And I want you to try and make a box with rounded corners in tech. You will find that you will have a hard time. So we already took a glimpse at that Typst not only includes markup, not only includes a good and consistent way to set and override your stuff, but we also just now saw a glimpse of the integrated scripting language that it contains. It's quite familiar to everyone who's already written Python or JavaScript, because we can just use functional programming as well and use this hashtag telling types that there is a markup expression, like we stop markup, we do a code expression here. Say, okay, give me an array, give me 4 numbers, 1 through 4. Make those numbers strings instead of numbers, and put ends in between them, and there you go. And you can take this to arbitrary complexity. You can import, use other files. You can bundle packages, and you can use scopes and every nice thing. And you don't have to worry about your registers being populated with other stuff. If you ever use LaTeX to program where you have like these prefixes and number blocks, nope, none of that. And next thing. Okay. When we did compile our paper with LaTeX, okay, we were happy, we were done, we did all the configuring. Okay, we wanted clean compile and entered this into our command line. Nice, nice, nice. LaTeX warning labels may have changed. Rerun to get cross-references right. Output written. And then you rerun it, and then you rerun bibtech if you're using that. Then you rerun it again and again for good measure, and then finally you surely have the final document. And why is this happening? And like, why is tech like this? Because every time, for example, you do a table of contents, imagine a table of contents. Okay, you print one in your document, and at the start, tech can't look into the future. So it prints an empty page. Okay, then you print your document, and then you can print the table of contents, because you now know from the previous compilation that it's written into the aux file, where were the headings. Oh no, my table of contents is 2 pages long, so now every heading is 1 page below where it used to be. So it's still not right. Okay, so I do write everything to the aux file again. I print this error message again, and I have the user recompile again. Okay, so far so good. So the cycle we need to do is recompile the project, check if every label converged, and recompile the project again, and eventually we can stop. What are we doing about this? Are we prescient? No. But we have integrated this cycle into our typesetting app, so you don't see it. We check for conversions for you and recompile, and only do the steps of recompilation because we retain abstract syntax trees and so forth that are actually necessary, so it's way faster. And you can even use this cycle in your own scripts by using, for example, this locate function, where the location of where it is called becomes available to you. And with this example, we're trying to produce these sorts of page headers that do spell out the last heading that came before that page. So we still know where we are as a nice navigational aid to our reader. So what we're telling it here is like, look for all headings that come before the location of our current page header. And if we did find any headings, and we take the last of those and write a line its body in italics. And you didn't have to write to an aux file yourself. Did you notice that? Okay, so you might ask me, I might ask what we are building. This seems complicated. How long does a compile take? They're instant. Look at me doing it on every keystroke. This message took 11 milliseconds to deliver. And if you want to learn more about how we're doing it, how we're building this incrementally executed scripting language in Typst, then you should go to the lightning talk of my co-founder Lawrence tomorrow in the main plenary at the end of the day. No other sessions, so you have no excuses. And listen to how we do it, because there's some really interesting stuff in there. As much as you can talk about in 5 minutes. And but we want to do more in the future. We still have some things on the roadmap because no relationship is perfect. And first of all, we want to start improving our output towards the world, because we think every pairing should make the world a better place. And this starts with accessible PDFs. This is an area which LaTeX struggled in for a long time, because they weren't able throughout macro expansion to retain the semantic meaning of the elements the user input, because we control the whole tree and it's actually a programming language and not macro expansion. We can keep them and produce accessible PDFs. And this leads right into HTML as well, because frankly, do we all consume technical content in print exclusively? No. We consume technical content exclusively in PDFs for print on our smartphones, where we pinch and zoom into the columns, and it's really, really bad experience. And so we want to go into the native format there. It's more convenient for users. It's also more accessible. And we want to do more flexible layout, even more possibilities to create stunning page layouts. So, okay, you described your dream system. How can I use it? Well, it's open source. And because it's written in Rust, you can easily install it on your system if you have current Rust installation by running cargo install git github.com/types/types. Or you can also download a pre-built binary from GitHub. Or you could use Nix to install it. If you, however, do want to sudo apt install it or have a snap, then please talk to the packagers who are surely here. And however, if you do think that installing something on your system is too much work, or if you want to work together with other people, you can sign up for our web app. If you do it through this link, you also get a nifty Ubuntu theme. And this now sounds bad and commercial. And like, do we have your data, and is it very, very slow? And are you sacrificing all of the compilation speed that we just gained by running it on your server and having the network round trip? No, we can compile our Rust code to WebAssembly, so it actually works offline on your machine, and we think that's really cool. So you have this native installed app performance in your web browser, and all this nice GUI around it, and can invite people to write with you. And that's my talk. And are there any questions?
Thanks. That's very impressive. Like, one question: is your presentation also done in Typst?
My presentation isn't, because we're missing drop shadows and animations. But we're looking at building those. Gradients just shipped, so that's covered. Lauren's presentation tomorrow will be.
Thank you.
Eye-opening. And I've been through the experience with LaTeX, and gladly didn't do this. But have you considered? So, okay, I have many, many questions. One of the first ones would be, what do the error messages look like when working with Typst?
Who would have thought? The error messages look like this. We have this, if you run it on the CLI, this nice watching compiler where you don't have to rerun the compiler, but it watches for the file to change. And if something is wrong, then you get okay, we're trying to set the text size to red. Something doesn't check out here. So expected length, found color, and it points to the red. Maybe the contrast is a bit bad here, but you can see the picture, and we try to build really helpful error messages. And in the web app, we actually also build like this whole as assistant, where if you have a document which is syntactically broken, just by clicking on the suggestions, you can step-by-step fix it.
Great. That's just one last question then. I see the scripting language and all the funny possibilities from there. You probably know already about the literate programming, the web, no web thing. Is that possible in Typst?
So literate programming. So what we do for literate programming, for example, if we document Typst code in Typst, is we do a bit of a hack, because think back to the code blocks you do in Markdown, where you at the top say what language it's in. We write a show rule that says, okay, look for the language, and if you see like example or something like this, then put on the left a box where you just evaluate the string that you got as Typst code, and on the right you put the code listing. And in a syntax highlighted way, because Typst uses itself to syntax highlight Typst. And then you got literate programming, and you can do the same thing for other programming languages because packages can ship WebAssembly plugins. Some crazy person ported a Python interpreter as a WebAssembly plugin, so it could do that, but I wouldn't recommend it from a performance perspective.
For now. Yeah, please.
How much production ready the thing is? Like, can I take it and do documentation tomorrow, which I want to be output in PDF and HTML?
So HTML is still on the roadmap. In terms of production readiness, already some time ago, people wrote their master theses in Typst. We have around about 2,000 users on our platform that each week use Typst really, really actively. It was our power user metric. And many more in open source, and we obviously don't want in the open part to ship a script that sends, hey, I'm the Typst compiler here on this machine to the server. So we don't know. But there are rough edges, but you could totally use it in a production use case.
Thank you.
A question about bibliography. What bibliography management systems I can use with this?
So you can just bring your BibTeX files. And what we are using is a CSL, that's citation style language, which is a technology that gives us all the citation styles that Zotero, the open source bibliography management system, supports. We also have our custom bibliography format based on YAML, which we think is better. But you are free to just use your BibTeX, and never mind if you're using BibTeX or our YAML, you always get the library of citation styles that Zotero also supports.
Anything that supports BibTeX will work with this tool.
Yes.
Thank you.
One more question. I think someone in the back.
Hi, thank you for the presentation. So, do you have anything planned for people that want to migrate from LaTeX to Typst?
So the great thing about this is that Pandoc actually already shipped support for Typst quite a while ago. So to get a first rough port of your LaTeX document, or Word or Markdown for that matter, to Typst, can just download Pandoc today and have it do the conversion. And we eventually plan to have it supported as a really nice user experience where we work together with the Pandoc team to improve support. Then users can drag their files into the Typst web app and it will convert them automatically in the cloud. But this is a bit in the future, I would say.
Thank you.
Yeah, and if you have any more questions, talk to me on the hallway.